Thanks to the James Webb Space Telescope, a discovery that seemed ordinary at first is now turning into something extraordinary. Meet LHS 1140b, a super-Earth in the constellation Cetus that might just be our next best hope for finding life beyond Earth. Astronomers at the University of Montréal are super excited about this planet they discovered a while back. At first, it seemed like just another barren exoplanet, nothing really interesting. But now new information from the James Webb Space Telescope shows that the planet is way more interesting than originally thought. It's a super-Earth that might just be able to support life. LHS 1140b is a super-Earth because it's almost 6 times more massive than our planet with a bigger radius. Gravity would be a lot stronger than here on Earth, and if life existed there, it would be a lot stranger or weirder than anything we've ever seen. When LHS 1140b was first found in 2017, astronomers thought it was like a mini Neptune with a thick atmosphere full of hydrogen and helium. But this is where the big news comes in. When the Webb telescope's powerful gaze was turned towards the exoplanet to get a look at the planet's atmosphere as it passed in front of its star, JWST's advanced instruments showed the planet's atmosphere of hydrogen and helium was actually not there at all, almost like it had disappeared. But what really happened is the James Webb Space Telescope instead found LHS 1140b has a nitrogen-rich atmosphere pretty much the same as our Earth's atmosphere. If this planet does have the same atmosphere as Earth, it could also have huge oceans of liquid water, much bigger than on our planet. And where there is liquid water and nitrogen, there's a really good chance to find some kind of life. Because LHS 1140b could be a rare super-Earth with massive liquid water oceans partially covered in ice, it makes it a #1 target in the search for alien life. The only other planet known to have liquid water on its surface is Earth. Of course, not everything on LHS 1140b would be the same as here on our planet. That's because this super-Earth is tidally locked to its red dwarf star. That means one side of the planet always faces its star. The ice would melt on this side of the planet, while the rest of the planet would be covered in ice, making LHS 1140b look like a big icy eyeball in space. Chances are high there could be some kind of life floating around in the oceans of that temperate zone. Webb is the most powerful telescope we've got in our arsenal, but it's really not the perfect telescope for looking at exoplanets. And right now, nothing has been proven yet, because using the JWST isn't so easy. Thanks to where the telescope is in space, it's only able to watch LHS 1140b move in front of its star 8 times a year. At the same time, the telescope is used by a lot of astronomers, and the waiting list is probably from here to the moon. It could be several years before we can confirm this planet has liquid water or ice. Right now, the same researchers that brought us this big news are hoping to get a few more hours of the Webb telescope's precious time to find out if water really does exist on this super-Earth. Maybe in the near future, we'll find out that this super-Earth is not only covered in water, it could be a massive ocean world filled with all kinds of bizarre alien life. The possibility of there being life on another planet out there is really exciting stuff. And it's not the only possible habitable exoplanet the Webb telescope found. Actually, the JWST found a lot more mysterious otherworldly stuff than just one new super-Earth. It found a lot more. In June 2024, some astronomers at the University of St Andrews found not only one potential super-Earth, but 3 of them, orbiting a nearby orange dwarf star about 55 light-years from us. Only the 3rd planet farthest away from the star sits in the habitable zone. But there's a little more excitement about this discovery because this orange dwarf star is a lot like our own solar-type star. It's a lot more stable and won't try to nuke the planets that formed around it with deadly radiation. We also know that a planet has to be a certain size and mass in order to hold life, and these 3 super-Earths have minimum masses ranging from 5 to 11 times that of our Earth. Anything over 15 times the mass of our Earth starts to create tougher conditions for life. Right now, all eyes are on the 3rd planet in the habitable zone that orbits this orange dwarf star every 151 Earth days. Could there be life on this planet? If the conditions are right, it sure could be possible. Astronomers want to get a closer look using high-contrast direct imaging and high-resolution spectroscopic imaging the Webb telescope is capable of. Will anyone find life on these planets? Only time will tell. One thing is certain, finding some clues that may answer the human race's long-standing question, are we alone, is always an exciting thing. We've been finding a ton of exoplanets out there. Some aren't really special, but once in a while, the Webb telescope does something really amazing and finds a mysterious new world. And this time, the telescope really showed off its incredible power. Astronomers from the Max Planck Institute for Astronomy used the JWST to grab this direct image from showing the gas giant planet Epsilon Indi AB. The spot in the middle of the image is where the JWST coronagraph blocks off the light from the exoplanet's host star, so that it's possible to see the planets around the star. The fact that we have a direct image of a planet that is 12 light-years away from us is utterly amazing. You probably thought, since it's the coldest exoplanet found to date, that it would be a freezing ice ball. But it's nothing like Neptune's moon Triton, which is a chilly -391 degrees Fahrenheit. It's actually much warmer, at 35 degrees Fahrenheit. It's actually around 180 degrees Fahrenheit warmer than Jupiter. Now, here's why all that temperature stuff is important. Some gas planets can be thousands of degrees warmer, but this gas giant's moderate temperature raises the possibility that clouds of gases like carbon dioxide, methane, and carbon monoxide could be present. And anywhere you find these ingredients, it's possible there could be life. Yes, we may have found another planet that could host life. And for our science fiction fans out there, you probably know that Epsilon Indi has been the site of Star Trek episodes, novels, and the video game Halo. Everyone, including astronomers, thought there might be planets in this system, and now it's really something to see actual planets being found. But now, for a moment, imagine a world where planets roam the galaxy without a star to call home. These aren't just ordinary planets, they're eerie, star-like bodies that defy what we know about how planets form. Astronomers call them zombie planets, and they're one of the most bizarre things ever found by the James Webb Space Telescope. This is where the line between planet and star starts to blur. An astronomer named Ray Jayawardena at Johns Hopkins University in Maryland and his colleagues found a rare family of 6 strange new worlds in the NGC 1333 star cluster that's 960 light-years away. The Webb telescope has taken hundreds of breathtaking images of NGC 1333. The newly found worlds in this star cluster are being called zombie planets because they formed like stars normally would. A really surprising thing found was the smallest of these worlds may be in the process of creating its own tiny solar system. They're giant too, like 5 to 10 times the size of Jupiter. But because these objects formed like stars, none of them orbits a star. Ray and his team believe these zombie planets probably formed from the collapse of clouds of dust and gas, basically the same way that stars like our Sun are born. So why didn't they turn into stars? The problem is these 6 strange planet-sized objects are big, but they aren't massive enough to sustain the nuclear fusion of hydrogen. Could there be life on any of these zombie planets? The probability is close to 0, but the more we learn about the universe, the more weird and unusual things we discover. The James Webb Space Telescope has been working overtime, and it didn't just discover these dark zombie planets, but it also found a strange zombie galaxy. And that ended up showing us a big secret about our own Milky Way galaxy. Out there in the distant universe, the JWST spotted a galaxy that stopped forming stars around 20 million years ago. It was thought to be a dead galaxy, but scientists were really surprised when they saw this galaxy come back to life. When scientists look at distant galaxies through telescopes, most of the time they see bursts of stars being born. But when they first saw this galaxy, they pronounced it dead because no new stars were seen forming. Because of the sheer amount of time that light took to travel to the telescope, astronomers were seeing the galaxy as it was 650 million years after the Big Bang. It's one of the earliest galaxies that we know of to form in our universe. Scientists were looking over data from this galaxy and found signatures of bright young stars, but they also found much older ones. This means that after 100 million years of forming, the galaxy went quiet for 20 million years. Then it suddenly came back to life and started to churn out stars again. To see a galaxy die and then come back to life is a very strange thing to discover. So what's the big secret that was found about our own galaxy? It turns out that our own Milky Way is a zombie too. That's right, we live inside a galaxy-wide zombie. The Milky Way has apparently been through a dead period once before, since its formation. A Japanese astronomer by the name of Masafumi Noguchi of Tohoku University looked at the history of the Milky Way. Imagine our galaxy, the Milky Way, like a giant living thing that's had a very busy life. According to Masafumi Noguchi, our galaxy has been around for about 10 billion years and has gone through two big periods where it made new stars. First, a long time ago, cold gas from space came into the Milky Way. This gas helped create the first stars. After a while, some of these stars exploded in huge bursts called supernovas. When these stars exploded, they spread out lots of new elements like oxygen and magnesium into the galaxy. This new material mixed with the gas and helped make more stars. But then, around 7 billion years ago, something big happened. Shock waves from other elements heated up the gas in the Milky Way so much that it stopped coming into the galaxy. This caused a long break where no new stars were formed for about 2 billion years. During this time, some of the older stars exploded, and their explosions added a lot of iron to the gas. About 5 billion years ago, the gas in the galaxy cooled down again. This cooling allowed the Milky Way to start making new stars once more. This second round of stars, including our Sun, had more iron in them compared to the first generation. So our galaxy has had a really exciting history, like it's had a few lives with breaks in between, during which it made new stars and then started again with a new batch of stars. Our Milky Way galaxy has numerous compact systems that are centered around stars similar to our Sun. However, planets orbiting closely to these stars are usually too hot and therefore unsuitable for supporting life. But when it comes to colder, fainter stars, the habitable zone around such stars is much closer. This is Gliese 667, a triple star system located in the constellation of Scorpius, just about 23 light-years from Earth. It contains the first known example of a system where a low-mass star has multiple potentially habitable rocky planets orbiting within its Goldilocks zone. Similarly to Alpha Centauri, the system has 3 stars. GJ667a is a K-type main sequence star and the largest one in the system. This orange red dwarf has a mass of 73%, a radius of 76%, and a visual luminosity only about 12% that of the Sun. At an average distance of 12.5 AU is its companion GJ667b. It's also a K-type orange-red dwarf, about 69% the mass of the Sun, and it radiates just about 5% of our star's visual luminosity. And just like with Alpha Centauri, the most interesting is the third star. Gliese 667c is an M-type red dwarf with a mass and radius only a third of the Sun. It's also incredibly faint, and a comparatively cold star with a surface temperature of 3,775 Kelvin. Yet, despite its small size, JJ667c has a surprisingly rich planetary system. Initially, scientists thought there were only 3 exoplanets orbiting Gliese 667c, but after revisiting existing data and making additional observations, they discovered there may actually be 6 planets in the planetary system, with 3 or even 4 of them being potentially habitable super-Earths. So what exactly is a super-Earth? The term is used to describe a planet that's larger than Earth, but not quite as large as the gas giants like Jupiter and Saturn. These planets can be made up of rock or a mixture of rock and ice, and they may have atmospheres that could support different life forms. The closest planet to the star, Gliese 667cb, is a scorching hot world at 200 degrees Celsius. Being the most massive one in the system, about 5.5 times that of Earth, this exoplanet probably has a very thick atmosphere and orbits its host star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are all located further away from their host star, and they all have masses between 1 and 5 times that of Earth, making them great candidates for habitability. Gliese 667cc, the next closest planet, orbits in the inner edge of the star's habitable zone. It has a mass about 3.8 and a radius 1.8 times that of Earth, and its year lasts just 28 Earth days. With the Earth Similarity Index of 0.85, it's known as the Holy Grail of extrasolar planets. Because of the low energy output, the habitable zone around the red dwarf JJ667c is located very near to the star, ranging from 0.11 AU to 0.23 AU, and is entirely contained within the orbit of Mercury. To compare, Earth is located at about 1 AU from the Sun. Our planet would be an ice world if it orbited star C at that distance. JJ667cc orbits its parent star 8 times closer, at approximately 0.12 AU, revolving around the red dwarf every 28 days. Because of such proximity, the exoplanet is likely to be tidally locked to the star, with eternal day on one side and eternal night on the other. Drastic temperature differences between the two sides probably have a major impact on the global climate on the exoplanet. Gliese 667cc gets about 10% less light than Earth does from the Sun, but since most of the light it receives is infrared, the planet gets about the same amount of energy as our planet does from the Sun, which would help retain water on its surface and result in a similar climate to Earth. Because scientists don't know for sure if the planet has an atmosphere and how thick it could be, it's impossible to predict the exact surface temperature on Gliese 667cc. If the planet does have an Earth-like atmosphere, it would transfer heat and equalize temperatures across the entire planet with a pleasant 30 degrees Celsius on the night side. Living on such a planet would be a much different experience. JJ667cc receives a faint reddish light from its star. The other 2 stars, Gliese 667a and b, are located at a distance of about 230 AU, much further than the distance between Pluto and the Sun, and outside the planetary system. However, the 2 other suns would still be seen as a pair of bright stars visible in daytime, and at night they would shine as bright as the full moon. And our Sun would appear as a distant star. Unfortunately, the nearby red dwarf is known to emit flares or intense bursts of radiation and energetic particles up to 1,000 times stronger than the flares on our Sun. This could be problematic for any potential life on the surface of Gliese 667cc, as the planet is located close to its flaring host star. And the strong magnetism of the red dwarf may cause star spots that can reduce the energy output of the star by up to 40% for months, which, combined with the lack of ultraviolet light emissions, would be another issue for the formation of life as we know it. Living on Gliese 667cc would be nothing like what we're used to, also because of how massive it is. The higher mass of the exoplanet means different gravitational acceleration on its surface. This world is rocky, and so the gravitational acceleration would be up to 60% higher than what we experience on Earth. A person weighing 75 kilograms on Earth would weigh as much as 120 kilograms on Gliese 667cc. In addition, a planet with higher mass can hold a more massive atmosphere, leading to higher atmospheric pressure at the planet's surface. In case it has an atmosphere similar to Earth's, the atmospheric pressure would only be a few times higher. But if the exoplanet has a Venus-like atmosphere, the pressure could be several hundred times greater, equivalent to the water pressure several kilometers deep in Earth's oceans. Despite its location in a habitable zone, Gliese 667cc may not have the same conditions as Earth. Life forms on Gliese 667cc may have to adapt to fluctuating and low light, a potentially high atmospheric pressure, and frequent flares. But this doesn't mean life cannot form on such a world. We've already seen examples of remarkable life adaptability on Earth. The two other potentially habitable planets are almost identical. Gliese 667ce and Gliese 667cf are both located farther out from their planet star, meaning they receive less energy. This could make them too cold to support life as we know it. But unlike with GJ 667cc, having a thick atmosphere would be beneficial for potential life on these planets, as it would trap heat and maintain favorable temperature conditions. Spotting 3 such worlds in the habitable zone of the same planetary system is extremely rare, but 4 is almost unthinkable. According to one study, 5 planets in the Gliese 667c system are estimated to receive solar radiation ranging from 20 to 200% of the current exposure of Earth to the Sun, which makes them all candidates for potential habitability. But there are other factors in play. Scientists have determined that for a planet with a mass equal to Earth, the habitable zone around Gliese 667c has 2 boundaries. The inner boundary lies between 0.095 and 0.126 astronomical units from the star, while the outer boundary lies between 0.241 and 0.251 AU. Any planet orbiting within these distances from star C may be able to sustain life, as it would have the right conditions for liquid water to exist on its surface. If a planet is too close to its star, the heat will cause water to turn into vapor and escape, making the planet uninhabitable. This happens because water vapor is a greenhouse gas which can trap heat and cause temperatures to rise to intolerable levels. Only the planets at the inner edge of the habitable zone with a larger mass are more resistant to the moist greenhouse effect. On the other hand, if a planet is too far away from its star, like the outermost Gliese 667g, it risks being covered in ice. While gases like CO2 can warm the planet and prevent this, too much CO2 can actually cool the planet down by reflecting light away. So there's a limit to how much CO2 can help warm a planet. In 2013, astronomers made an announcement that Gliese 667c has a minimum of 6 planets, and there's a possibility of a 7th planet designated as GJ 667ch. Although highly controversial, the exoplanet could be the smallest one found so far around star C, with a mass of at least 1.1 times that of Earth, located just between the planets C and B. Because of its mass and proximity to the parent star, the planet H would be too hot for any life to form. But planets F and E are confirmed to orbit in the habitable zone, and although the estimated location of the planet D is outside the outer edge of the habitable zone, its orbit is still uncertain. This means Gliese 667 CC, CF, CE and possibly even CD are all potential habitable worlds. The discovery of densely packed planetary systems around M-dwarf stars, such as Gliese 667c, points to the existence of numerous populations of planetary systems out there, each with several potentially habitable planets. And since M-dwarfs account for more than 70% of all stars in our cosmic neighborhood, the number of such promising planetary systems in our galaxy is likely to be much greater than ever thought. Instead of searching for a single potential habitable planet among 10 stars, scientists can now focus on one star to find multiple Earth 2.0 candidates. As new and advanced telescopes are being developed, our ability to uncover the mysteries of the universe is growing at an exponential rate. The James Webb Space Telescope was built to study the early universe, back when the first galaxies and stars were forming. But what makes it really special is its ability to analyze atmospheres around distant exoplanets. The telescope's near-infrared spectrograph and the mid-infrared instrument are able to measure a different spectrum of light emitted by faraway celestial bodies. This helps scientists identify the composition and temperatures of planets and their atmospheres. And on top of that, JWST has a powerful infrared camera that can see through an exoplanet's thick cloud cover and help us study its geology. The problem is, TRAPPIST-1 is an M-type red dwarf, which are the most prevalent in our galaxy and the most active stars we know of, emitting powerful flares several times a day. And since studying an exoplanet's atmosphere takes observing light as it passes through it, it's difficult for scientists to distinguish ordinary light from the stellar radiation caused by the flares. But the James Webb Space Telescope is much more powerful than any other telescope known to science. Its precision in detecting brightness fluctuations is comparable to looking at 10,000 light bulbs and seeing 4 of them being turned off. So what has the telescope discovered about the TRAPPIST-1 system so far? Recent observations showed that the closest planet to the star in the TRAPPIST-1 system either has a very thin atmosphere or none at all, and is most likely a bare rock. This innermost planet, called TRAPPIST-1b, is a scorching hot rocky world with a blistering surface temperature of 450 degrees Fahrenheit. The planet is too close to its parent star, much like Mercury in our solar system, which places it outside of the habitable zone. Slightly farther out, another planet rotates around the red dwarf, TRAPPIST-1c. In the past, it was believed that the second planet in the TRAPPIST-1 system was similar to Venus, but the data from James Webb Telescope proved scientists wrong. The planet doesn't have a Venus-like thick atmosphere, and while the temperatures on the day side of this world are still extremely hot, about 225 degrees Fahrenheit, it is now considered the coldest rocky planet ever studied using this new method. In such harsh conditions, water would have evaporated long ago, even if it was initially present on these worlds. But according to a new study, the rest of the planetary system might have stayed cold enough for water to remain there, either in liquid or frozen form. The lightest of the planets in this system, TRAPPIST-1d, has around 30% the mass of the Earth and a radius of approximately 80% of our planet. Because of such small mass, the planet probably doesn't have a dense atmosphere or an abundance of heavy elements, but it still bears similarities with Earth, such as the amount of solar radiation it gets from its star. Located just on the inner edge of the habitable zone, the planet's temperature without an atmosphere would be about 48 degrees Fahrenheit. To compare, if there were no greenhouse effect on Earth, the surface temperature would be freezing, about 0 degrees Fahrenheit. But what's exciting about this world is that it could harbor a staggering 250 times more water than our own planet, although the planet's potential habitability remains uncertain. But there's one factor that might change this. It's known as albedo, which is a measure of the reflectivity of a surface, typically expressed as a percentage. It quantifies how much incoming solar radiation is reflected back into space by a surface, rather than being absorbed. In other words, it describes the ability of an object or surface to reflect sunlight. Albedo values range from 0 to 1, with 0 indicating that all incoming radiation is absorbed by a perfectly black surface, and 1 indicating that all incoming radiation is reflected by a perfectly white surface. The Earth's average albedo is 0.3, and so if TRAPPIST-1d has the same or similar value, it could provide an environment suitable for some forms of life. This is because water vapor acts as a greenhouse gas, but with Earth-like albedo, the planet would escape the runaway greenhouse state. Scientists think TRAPPIST-1d is covered by a global ocean, but for life to thrive there, it needs a tidal heat flux 20 times stronger than what Earth has. Tidal heat flux is like a special kind of energy generated by the gravitational interactions with nearby celestial objects. On TRAPPIST-1d, this energy would act like geothermal heat that could sustain chemical reactions in its gigantic ocean. Some forms of life derive energy from chemosynthesis rather than photosynthesis, even here on Earth. So there's a possibility that TRAPPIST-1d could be a unique home for life that doesn't rely on sunlight. and if the planet has a thin atmosphere, its twilight zone, or the border between the night and day sides, could be habitable as well. Among the planets in the TRAPPIST-1 system, the fourth one, TRAPPIST-1e, is the most promising. It's both dense and possibly quite rocky, sharing similarities with our home planet, even in composition. Located in the habitable zone of its parent star, TRAPPIST-1e could hold a thick oxygen-rich atmosphere, and all the hydrogen could have escaped its atmosphere because of how light it is, which is good news since it's a greenhouse gas. If TRAPPIST-1e began with more water than Earth and Mars and retained it on the surface over time, its climate could be strikingly similar to what we enjoy on our own planet. That being said, TRAPPIST-1e is considered one of the most Earth-like planets ever discovered. Imagine living in a world where a year lasts about 7 Earth days, and the concept of day and night is something completely different from what we're used to. Because of the close proximity to their star, all the 7 planets in the system are tidally locked, with one side always facing their parent star. During a never-ending sunset or sunrise, the sky would be a reddish hue, and you'd be able to see the 6 planets in the sky as if they were moons, with some appearing larger than the Earth's moon in the sky. On its day side, the planet might even have lands where humans could thrive. The climate would be much different. Thick storm clouds covering large areas, massive dust storms distributing heat across the planet and maintaining a temperature balance necessary for complex ecosystems to flourish, while also generating powerful winds, tornadoes, and hurricanes. The night side would be a harsh place, even for expeditions. This is the realm of Arctic cold and towering glaciers that dominate the landscape. Although a constant twilight might get a bit tiresome, it offers a crucial advantage, especially for the first settlers. In the distant past, our ancestors used the ever-shifting constellations as direction guides, but on TRAPPIST-1e, the nearby star is always at a fixed position in the sky. So it would be like having a permanent North Star to show you the way through the uncharted territories of this alien terrain, although it would appear several times larger than the Sun. In our galaxy, there are 10 times more of these M-type red dwarf stars than stars like our Sun. These little red dwarfs hold promise as potential cradles for life, with trillions of years for life to evolve and flourish in their cosmic neighborhoods. However, as we've mentioned earlier, even though they're normally dim, many red dwarfs can suddenly and dramatically increase their brightness. This supercharged mode is like a star shooting out solar flares on steroids. Some scientists think that the flares from the TRAPPIST-1 star might actually be helpful for life on the nearby planets. These flares give off a lot of energy, and that energy could have kick-started the creation of important molecules like amino acids, which are building blocks for life. So, while the high-energy radiation from flares could be harmful and may even sterilize a planet's surface or strip away its atmosphere, it could also provide the extra energy needed for early forms of life to develop. Although data shows TRAPPIST-1 is a much safer host star, its flares are about 30 times milder than those seen in other red dwarfs. But since the 7 planets in the TRAPPIST-1 system are tightly packed, the effects would be noticeable. And this means that auroras on TRAPPIST-1e would be nothing like the ones we know. Human bodies are fragile, so even weaker but frequent solar flares from the star pose a constant danger. Here, auroras act as natural alarms, signaling the incoming flare. To survive, inhabitants would rely on an exponentially thicker ozone layer and a strong magnetosphere, along with advanced technology to track and respond to these volatile solar events. For safety, colonizers of the planet could construct specialized shelters resembling bunkers. These shelters would be equipped with shielding materials and advanced life support systems, serving as a refuge during periods of intense space radiation, and they'd be built into every habitat. Moving wouldn't be much different, as the planet has gravity about 93% that of Earth. But if you don't find a safe place to hide once solar flares strike the planet, your arteries might contract, which can impair blood flow, leading to critical health problems. Exposure to this extreme stellar radiation can also damage the DNA within your cells, disrupting the normal cell production rate, causing mutations or a growth of abnormal cells. In this world of constant twilight, growing plants becomes a puzzle. The starlight reaches the planet's surface at a low angle, which can cast shadows and limit plant growth. To overcome this, humans might consider a concept like the Hanging Gardens of Babylon, letting vegetation drape from multi-level platforms to catch sunlight from different directions. Imagine a series of tiered planter boxes, each placed on top of the one below. Plants are spaced and designed to allow sunlight to filter down through the tiers, so even if a plant on a lower level is partially shaded by the plants above it, it still gets some sunlight from the sides or through small gaps in between vegetation, making the most of the available sunlight. The idea is similar to the vertical gardens created by nature, where every inch of space is optimized for plant growth. If there's native flora on the planet, it might not need a human hand to thrive, since it has probably evolved to be completely black to absorb more of the sunlight. Another idea is some vegetation might also evolve into bioluminescent organisms, emitting their own soft glow to compensate for the lack of natural light. This adaptation would extend their growing hours and enhance their chances of survival in the persistent twilight. Located a bit farther from its parent star, Trappist-1F only receives about a third of the starlight compared to what Earth gets from the Sun. This makes this world much cooler. If there's no atmosphere around Trappist-1F, its surface temperature would be approximately -74 degrees Fahrenheit, turning any potentially existing water there into ice. The same would happen on the two outermost planets, Trappist-1G and H. Although the data shows they are rich in water, their surface would be covered in ice. However, since Trappist-1G is about 30% more massive than Earth, it could potentially hold on to its atmosphere. If the planet managed to preserve this heat-distributing layer and has active volcanism to fulfill greenhouse gases needed to sustain that atmosphere, the planet might still be a water world. Or maybe there's a subsurface liquid water ocean on this planet that hides exotic forms of life. If it exists, scientists speculate that the ocean could be 415 miles deep. To put this into perspective, the average depth of the Earth's global ocean is around 2.3 miles. The corner of the Trappist-1 system, where the seventh planet orbits, doesn't get bathed in much stellar radiation. If the planet was orbiting inside our solar system, it would be somewhere between Mars and Jupiter. According to estimations, the surface of the Trappist-1H is a chilling -148 degrees Fahrenheit. Trappist-1 is an aging star that's been cooling for 7.6 billion years since its birth. The nearby planets were once exposed to extreme conditions due to the intense heat. In theory, this heat should have caused any water present on these celestial bodies to turn into vapor and concentrate in their atmospheres. Later, as extreme stellar winds hit the planets, this water would escape into space. However, astronomers have been working on more accurate models of planetary atmospheres based on real data. In the past, it was believed that heat escaped from a planet's surface through convection, a process similar to hot air rising and cold air falling. But celestial objects are more complex than that, and the gases in their atmospheres act differently at different altitudes. Recent research suggests that the Trappist-1 planets might not have heated up enough to turn their crust and mantle into molten rock. This means that a significant amount of water might have remained trapped within the rocks, even after the star cooled down. Currently, the conditions on these planets might be extreme. Although red dwarfs are known for their remarkable longevity, and so the 7 Trappist worlds have billions and trillions of years to go through countless stages of evolution. Until one day, what is currently scorching or freezing turns into a more hospitable environment, teeming with life as we understand it. Many studies have been done and concluded that life has more chances to emerge around red dwarfs than stars like our Sun. And there are more red dwarfs than any other type of star in the universe. Red dwarfs are also the smallest type of hydrogen-burning star. In 2023, astronomers stumbled across an intriguing exoplanet around the red dwarf star TOI 715, located in the constellation of Volans, 136 light-years away from us. Astronomically speaking, this is our celestial neighborhood, like a house just down the block from where we live. The red dwarf star TOI 715 is orbited by the super-Earth planet TOI 715b. What defines an exoplanet as a super-Earth is its mass, which has to surpass that of Earth. TOI 715b is 3 times as massive as our planet, and it's about 1.5 times the Earth's radius. To even consider a space object habitable, among all other things, it has to be either a water world or a rocky planet. By analyzing the exoplanet's parameters, scientists can make predictions about its composition, determining whether it falls into the category of a gaseous, rocky, or watery world. Usually, planets that are between 2 and 10 Earth masses, and a diameter between that of our planet and Neptune, turn out to be rocky. But it's not only the exoplanet's mass and size that makes it special. Located at just the right distance from its star, TOI 715b receives enough heat to possibly have liquid water on its surface. And where there's water, there could be life. Red dwarfs like TOI 715 often have several worlds tightly packed within their habitable zone. Astronomers theorize that there could be one more planet in the system, just about 7% larger than Earth. If the theory holds true, it will be the smallest exoplanet ever discovered in the habitable zone by NASA's Transiting Exoplanet Survey satellite. In our cosmic quest to find habitable worlds, planets like TOI 715b seem to be our best contenders. Despite our limited knowledge about this newfound exoplanet and its potential neighbors, imagine the excitement if future observations uncover an atmosphere and even bodies of liquid on its surface like those we've once spotted on Saturn's largest moon, Titan. The possibilities are thrilling. Perhaps one day, our descendants will be navigating vast, uncharted landscapes, seeing the unknown creatures roaming around this alien terrain. But let's move on to other recently discovered exoplanets. Unfortunately, not many exoplanets we find are habitable, even in theory. Some have conditions so terrifying, we wonder how they came to exist. On average, chances of finding an inhospitable exoplanet are much higher, and these planets raise a lot of questions within the scientific community. One of such celestial marvels sits at a distance of around 264 light-years from Earth. So, what's so special about it? What you see here is one of the planets called ultra-hot Neptunes. But LTT 9779b isn't just that, it's the most reflective exoplanet we've ever detected. The blazing hot world is roughly 5 times wider than Earth, and it reflects about 80% of the light coming from its star. To compare, Earth only reflects about 30% of sunlight. What makes it a gigantic cosmic mirror is an abundance of reflective clouds of metal, with titanium droplets raining down on its surface. The problem is, as scientists say, it's a planet that shouldn't exist. The side of the exoplanet that faces its host star is extremely hot. So hot that neither clouds of water nor even clouds of glass or metal should form in its atmosphere. According to our current understanding, a star located this close to an exoplanet should strip away its atmosphere completely. So what happened there? Researchers compared the phenomenon to condensation in a steamy bathroom. If you let the cool air in, water vapor will condense, and if you let the hot water run, eventually the air will be so full of vapor it wouldn't be able to hold any more. Something similar could have happened on this ultra-hot Neptune, when the planet's atmosphere was filled with silicate and metal vapor because of the scorching temperatures on its day side. But the exoplanet's uniqueness doesn't end here. Throughout decades of observations, we've detected a multitude of worlds orbiting their host stars in under 1 Earth day at a very close proximity. But all of them were either hot Jupiters, 10 times wider than Earth, or rocky planets over 2 times smaller in size than Earth. There was a population of missing planets, the sizes of which would fit between these categories. Scientists call this gap the Neptunian desert, until finally we've stumbled across LTT 9779b, which, by its parameters, fits right in the middle. In a way, the exoplanet's reflectivity is its survival mechanism. If it absorbed much more heat from its star, over time, the planet would slowly evaporate. LTT 9779b is a perfect target for follow-up observations by the Hubble and the James Webb Space Telescopes. Perhaps our technologies will reveal even more mysteries behind this already enigmatic celestial object in years to come. The planet we're about to discuss was discovered over a decade ago, but scientists have recently learned something about it that deserves the spot on our list. WSP-76b is nearly half as hot as our Sun, almost twice as wide as Jupiter, but just about 90% its mass. The scorching temperatures are explained by the planet's close orbit around its star, just about 3% the Earth-Sun distance. Even the closest planet to the Sun, Mercury, is located 10 times further away. The place would be a perfect crematorium, since human bones, which primarily consist of calcium, vaporize at approximately 1500 degrees Celsius. On top of that, one of the planet's sides is tidally locked to the yellow-white WSP-76 star, which results in different temperatures across the exoplanet and brings about a weird phenomenon. Throughout the years since the planet's discovery, researchers have studied the composition of the exoplanet, discovering 11 chemical elements in its atmosphere, some of which turned out to be rock forming, or at least that's what happens to them on terrestrial worlds like Earth. But because of the blisteringly hot temperatures on WSP-76b, elements like magnesium and iron turn into gases that reside in the planet's upper atmosphere. And once strong winds carry these iron and magnesium vapors to the night side of the planet, they cool and rain down as molten droplets of metal. It would have been a fascinating view to observe, which would probably look something like this. Astronomers have also detected a surprisingly higher amount of nickel in the planet's atmosphere, which could mean that in the past, WSP-76b swallowed a tiny rocky world like Mercury that contained an abundance of this element. Some planets out there in the universe are extremely different from what we have in the solar system, and WSP-76b isn't even the most drastic example. Recently, astronomers uncovered an extraordinary star system just 100 light-years away. Dubbed HD 110067, it contains 6 sub-Neptunes, planets 2 to 3 times the Earth's size. All of the exoplanets in the system are unusually close to their host star, and with orbits that would fit in between Mercury and the Sun. Unlike our solar system that's been continuously changing, HD 110067 appears to have maintained its structure for over 1 billion years. The 6 planets are synchronized in one perfect celestial dance that scientists call resonance. The way these sub-Neptunes orbit resembles fractions in a mathematical equation. By the time the first planet completes 3 orbits, the second world revolves around its star twice. Each subsequent planet follows the rhythm, with the 4th sub-Neptune, for example, orbiting the star 4 times for every 3 orbits of the 5th planet, and so on. This discovery is exceptionally rare. Usually, young planets maintain these rhythms for a brief period until something goes wrong, like a passing star or more massive planets in the same system, disrupting the balance due to their strong gravitational influence. Over 1,000 light-years away, in the constellation Pictor, sits a binary star system Bebop-1. That's where scientists have recently identified a new member, the exoplanet Bebop-1c. And it's not a typical planet as we know them. It belongs to the category called Circumbinary planets, or such that orbit 2 stars instead of 1. They're quite scarce in our cosmic catalogue, with only about 15 known so far, but there's more. It's the second circumbinary system that hosts more than 1 planet we've ever been able to detect. Interestingly, about 85% of stars in the universe aren't like the Sun. They usually have 1 or more stellar companions. In the Milky Way alone, there are systems with clusters of 7 stars. Based on our current understanding, single stars only make up about 15% of all stars in the cosmos. The newly discovered world is approximately 65 times more massive than Earth, which makes it a gas giant like Jupiter or Saturn. Just imagine how breathtaking it would be to stand on its surface, surrounded by a double sunrise. Unlike ordinary disks of matter surrounding a single star, in circumbinary systems, the planet-forming disks rotate around both stars, creating disturbances that make it challenging for planets to form. As a result, it's only in the calm corners, away from the stellar chaos, that planets have a chance to be born. Discoveries like this remind us of the endless celestial gems we're still about to uncover, even those that were once purely science fiction. GJ9827d is the planet known since 2017, but just recently, the Hubble Space Telescope has made an astonishing discovery about this world. The exoplanet is twice the size of Earth and about as hot as Venus. What you would never expect to find there is water, the key ingredient for life as we know it. But fingerprints of water molecules is exactly what the Hubble telescope revealed over 3 years of observations as the planet completed 11 transits, 11 times when it crossed in front of its host star. The atmosphere of GJ9827b appears rich in water, and if the measurements are correct, this will be the first time scientists directly prove the existence of worlds with watery atmospheres around stars unlike ours. The planet may have initially formed in a frigid region farther from its star, where low temperatures kept its water in the form of ice. Later, it migrated closer, slowly losing hydrogen due to its intense radiation. Or it might have originated close to the hot star in the first place, with traces of water already present in its atmosphere. Although even if that were true, this would still be a steamy hot world, where life forms we're familiar with wouldn't be able to survive. The next step for scientists is to examine data gathered by the James Webb Space Telescope, which will hopefully provide more clarity about the nature of water-rich worlds beyond our solar system. As for the search for habitable worlds, a recent study suggests a new method to detect such planets based on the role of carbon monoxide in the atmosphere of exoplanets. When the production of carbon monoxide outruns its removal, something known as CO runaway, it can have an effect on the emergence of life on Earth-like worlds orbiting Sun-like stars. In our Milky Way galaxy, there are potentially 40 billion such planets. By observing atmospheric dynamics of distant worlds, astronomers can focus on best candidates for habitable and even potentially inhabited exoplanets. In the quest for potentially habitable planets, scientists seek out twin Earths, planets that closely resemble our own. A twin Earth is characterized by a size similar to that of Earth, which increases the probability of having a rocky surface. Additionally, it's essential for the planet to orbit a star akin in size and radiation output to our Sun, while maintaining an optimal distance within the habitable or Goldilocks zone. Kepler 452b was the first Earth-like planet found orbiting around a star like the Sun, and it might just be a perfect candidate as a habitable world. Back in 2015, scientists considered it the most Earth-like planet ever discovered, and there's a reason for that. Like the Sun, Kepler 452 is also a G-type star of about the same temperature, but 1.5 billion years older. Even though the star is brighter and slightly larger in diameter than the Sun, solar energy that reaches the exoplanet is just about 10% more than what Earth receives. At 1.6 times our planet's size, there's more than a 50% chance this super-Earth is a rocky world. Even the orbits of the two planets are similar. Kepler 452b is located in the habitable zone of its star, about 5% farther compared to Earth and the Sun distance. Scientists believe that the planet had a valuable head start in the development of life compared to Earth, as it spent 6 billion years in the star's habitable zone. Of course, this is only if Kepler 452b had all the right conditions for life to emerge on its surface in the first place. However, we've recently discovered that Kepler meets some of those conditions. One study shows that if the exoplanet's CO2 concentrations in the atmosphere are similar to the atmospheric amounts of gas observed on Earth, the exoplanet is habitable. So, what would it be like to live in this alien world? Because the planet is more massive than Earth, it would also likely have a stronger surface gravity. In the new environment, people would need to acclimate to their altered weight, experiencing a sensation of being approximately twice as heavy as they are on our planet. Initially, humans would encounter mobility challenges, but over time, we would undergo adaptation, paving the way for the natural course of evolution to unfold. Former NASA's astronaut believes that just like firefighters carrying heavy loads, our bodies would adapt to the new environment, gradually growing stronger. Through heightened physical activity, our bones would develop resilience, countering a potent gravitational force pulling us towards the ground. Over generations, kids would be born with inherently robust physiques, surpassing the physical resilience of Earth-born infants. Not everything, however, would be different. Thanks to its current proximity to the star, Kepler 452b would feel much like home when it comes to sunshine and surface temperature. Planets would still rely on photosynthesis as their primary source of energy, maintaining a growth pace and intensity akin to that observed on Earth. Scientists also speculate the exoplanet might have a thick atmosphere, water on its surface, and active volcanoes. If most predictions are correct, Kepler 452b is a very promising candidate for Earth 2.0. But it might not stay like that for long. Researchers think the planet might experience a runaway greenhouse effect in about 500 million years, the same phenomenon that made Venus a scorching world by trapping high amounts of carbon dioxide in the planet's atmosphere, making it 90 times as thick as Earth's. Still, that's 500 million years, plenty enough time for the human race to colonize it and call it a home world. Kepler 452b seems exciting, but it's not the only Kepler world that shows promise, and it's a really distant one at that. Even light would take 1,800 years to reach this exoplanet. But what if we take the fastest man-made object ever created? Breaking its own speed records as it approaches our Sun, the Parker Solar Probe is soaring at a speed of 120 miles per second. This is a striking achievement, and yet it's still only 0.063% of the speed of light. If we imagine a direct journey from Earth to the exoplanet Kepler 452b, the probe would still require an astonishing 2.8 million years to traverse the vast expanse of 1,800 light-years. "500 light-years away from Earth, within the constellation Cygnus, lies Kepler 186, a red dwarf star. It is this celestial location where scientists discovered the first Earth-sized exoplanet orbiting a distant star in the habitable zone. Since then, astronomers are confident there are multiple worlds in the universe similar to Earth in diameter and could have conditions that would allow for the existence of liquid water on their surface. Kepler 186f only exceeds the size of our planet by less than 10%. With an orbital period of 130 days, this alien world resides towards the outer boundaries of the habitable zone. Because of this, Kepler 186f receives approximately 1/3 of the heat energy the Earth receives from the Sun, rendering its conditions more akin to those on Mars. However, rather than being a misfortune, this disparity offers a unique advantage. Red dwarfs are known to have powerful solar flares, increasing their brightness twice within minutes. But Kepler 186 star is smaller, less massive, cooler, and nowhere near as bright as the Sun. So, even if the M-type star experiences frequent outbursts of radiation, the exoplanet might be far enough to avoid the deadly consequences. The potential for liquid water and the existence of life on Kepler 186f are not solely determined by the planet's distance from its star, but also by its atmospheric conditions. The exoplanet's current position could indicate frozen water on the surface. However, its large size allows for a denser atmosphere compared to the Earth that can retain and distribute heat, potentially warming the water. The 4 other planets within the system are only about half the size of our planet, and all of them have short orbital periods, which makes the inner star companions extremely hot worlds unsuitable for life as we currently understand it. Today, it would take a 780,000-year journey to reach Kepler 186f. But imagine that sometime in the distant future, we invent a spacecraft with a speed limit of 90% the speed of light. In about 550 years, our descendants would step foot on Kepler 186f. What would their experience be like? The red dwarf star Kepler 186 is smaller and about 25 times fainter than our Sun. If you were standing on the exoplanet's surface at midday, the star's brightness would be similar to our Sun's about an hour before sunset. Scientists say the planet maintains a stable axial tilt, enabling it to have regular seasons and a consistent climate, just like here on Earth. Based on calculations, scientists have determined that the axial tilt of Kepler 186f has remained stable for an extensive period of tens of millions of years. Such stability is crucial, as an erratic tilt can have catastrophic consequences, transforming a potentially habitable planet into a barren and inhospitable world. Think of Mars, where an unstable tilt might have played a key role in shaping its current unfavorable conditions. The search for the perfect Goldilocks planet continues, and some of the best candidates are often found by chance. In 2020, Kepler 1649c was accidentally discovered during a review of past observations, after initially being misclassified as a false positive exoplanet. Scientists still don't know much about this world, including what its atmosphere could be. But since Kepler 1649c receives 75% of starlight compared to Earth, and because of its much shorter orbital period of just 19.5 days, it might have temperatures similar to those we experience here on our planet. If Kepler 186f lacked a heat-trapping atmosphere, its surface temperatures would be around minus 38 degrees Fahrenheit. Although this may not seem favorable, Earth's temperatures without greenhouse gases would also be lower, around 0 degrees Fahrenheit. Even if the atmospheres of the two planets were similar, Kepler 186f would still require more greenhouse gases to compensate for this difference. Many other worlds in the cosmos bear resemblance to Earth in terms of temperature or size, like Trappist 1f, Trappist 1d, Teegarden C, and TOI 700d. And these exoplanets are located much closer to us. So far, Kepler 1649c seems unattainable. The vast expanse of 470,000 years of travel time lies between us. But when time comes, it would be a worthwhile journey, as none of these nearby planets can match the unique combination found in Kepler 1649c. This extraordinary exoplanet not only potentially shares our planet's temperature and size characteristics, but also resides comfortably within the habitable zone of its star, making it a truly exceptional discovery. The star system has a second planet called Kepler 1649b that's roughly 8% larger than Earth, but located much closer to the red dwarf. Because of the quite unusual 4 to 9 orbit period ratio between the two worlds, there's potentially a third planet hiding in the system. Soon enough, next-generation observatories will give us more clues on the habitability of these worlds. Meanwhile, we'll explore yet another impressive celestial body lurking 1,100 light-years away in the constellation of Lyra. Every 112 days, Kepler 442b orbits a K-type star at about half the Earth-Sun distance. Such a close proximity might lead to multiple issues for the well-being of any potential life forms present on the exoplanet. Typically, planets that orbit close to their host stars become tidally locked, resulting in a potentially harsh environment on their surfaces. However, Kepler 442b is situated just outside the range where the star's gravitational forces could cause tidal locking. K-type stars are generally dimmer compared to the Sun. Additionally, Kepler 442 itself is a smaller and cooler star, so the exoplanet around it finds itself in an optimal position, approximately 0.4 astronomical units away from its relatively tranquil host star. Scientists consider K-type stars as a sweet spot in the search for habitable worlds. Although they aren't as bright as G-type stars and not as long-living as M-type red dwarfs, they offer a favorable combination of properties. Only within 100 light-years of our Sun lie at least 1,000 K stars. These orange dwarfs can exist between 15 to 45 billion years, and throughout the entire lifespan of our Sun, which is about 10 billion years, orange dwarfs only gain approximately 10 to 15% in their brightness. All the while, our Sun can make the Earth uninhabitable in a mere 1 to 2 billion years. So, how promising is Kepler 442b? Astronomers like to categorize planets based on their potential habitability. The updated scale, called the Comparative Habitability Index, improves upon previous methods by considering multiple factors. It takes into account the planet's composition, favoring rocky planets, as well as the eccentricity of its orbit, which affects the stability of light and heat received from the star. Additionally, the scale considers the albedo, which measures the amount of solar energy reflected by the planet's atmosphere. These combined factors play a crucial role in determining the habitability, even in cases where the orbit is irregular. Just like the Earth Similarity Index, the Comparative Habitability Index ranges from 0 to 1, with a higher value indicating a higher potential for habitability. On both scales, Kepler 442b has been assigned a value of approximately 0.84. Unfortunately, the exoplanet is too dim and small to be directly imaged with our current telescopes, let alone travel to Kepler 442b, which would take 1,700,000 years on the fastest space probe ever created. What we can do, however, is look at its biosphere. In one study dedicated to examining radiation levels received by potentially habitable exoplanets, Kepler 442b stood out as particularly interesting. It receives nearly sufficient sunshine to support a significant biosphere that could be detectable by the James Webb Space Telescope. As the JWST studies this world, we might also want it to extend its observation to 2 other intriguing exoplanets within the same constellation. In the Kepler 62 star system, 2 planets reside comfortably in the habitable zone. The remaining trio of planets in the system orbit too closely to the K-type star, causing them to be excessively hot and unsuitable for sustaining life. Scientists find Kepler 62e and Kepler 62f particularly intriguing, as they are potentially water-rich worlds. These exoplanets have Earth Similarity Index rankings of 0.83 and 0.69 respectively. Kepler 62e completes an orbit around its star every 122 days, while Kepler 62f has a longer orbital period of 267 days. The atmosphere of Kepler 62e is believed to be densely clouded, and the planet is thought to have a consistently warm and humid climate, extending even to its polar regions. These conditions make it an exceptionally favorable environment for supporting life. A study from 2014 suggested a possibility of a large moon in orbit of Kepler 62e. If that's the case, the odds of the exoplanet being a habitable world would increase even more. This is because large moons are necessary for the evolution of complex life. Through tidal forces, they help regulate the planet's rotation and axial tilt, which has a direct impact on its climate patterns. Moons also provide a protective shield, deflecting or absorbing potential impacts from asteroids or comets, thereby safeguarding the planet and its inhabitants. Although a further located Kepler 62f would mean cooler temperatures on its surface, it still holds potential to be life-friendly. But even if this hypothesis holds true, envisioning a technologically advanced civilization seems challenging, given the absence of land, metals, and the fundamental element of fire. Processes like metallurgy, vital for technological progress, would seemingly be unattainable. Nevertheless, nature's complexity opens a possibility of creatures far more inventive than ourselves, capable of finding alternative ways to surpass our current technological achievements, perhaps even if they live underwater. If humanity decided to send a message on board Parker Solar Probe to any intelligent extraterrestrial life possibly inhabiting these strange worlds, they would receive it no sooner than 1,850,000 years from now. But if we sent a radio signal today, it would reach the 2 exoplanets in a mere 1,200 years, blink of an eye on a grand cosmic scale. While Kepler-62e and Kepler-62f are no ideal twin Earths today, the ever-changing nature of planetary systems holds the promise that these worlds can undergo transformative changes. Our own planet was once entirely submerged in oceans, and yet over time, it transformed into a diverse world of both land and water. Researchers contemplate the future development of these exoplanets, speculating that they too may eventually evolve into environments reminiscent of Earth, with a harmonious interplay between expansive lands and surrounding oceans. Meanwhile, even here on Earth, we have something as weird as flying fish, so it's not unreasonable to assume that were living organisms to exist on these two exoplanets, they could be quite sophisticated. One of the biggest challenges in studying distant worlds has been the vast distances involved. However, we may not have to wait for super advanced telescopes to address this challenge. Data from Kepler and the European Space Agency shows that among all Sun-like stars in the universe, half could host potentially habitable rocky worlds, and some of these stars could be lurking in our cosmic neighborhood. This means there's a 95% chance of at least one twin Earth hiding somewhere within 20 light-years from us. How long do you think till we verify a completely habitable world in a close vicinity of our solar system? And how will this discovery change the course of human history? Let us know what you think in the comments. Make sure to stay tuned here to learn more about our planet and the cosmos. Thanks for watching.